Okay, this is going to be just a last semi-short video that shows how to do some of the things that we ask you to do in the final as far as visualization goes. So we're going to ask you to do a forest plot, which is the first thing I'll show you here. And then we also are going to ask you for two tables. So one table to display the descriptives of the variables in your model, and then another table that is your regression table that gives us your regression output. And the things that I'm going to show you are like kind of extra. You don't have to use them. If you find it easier to like create a table in Excel or something like that, that's perfectly fine, just so long as you're presenting the results to us in some sort of table format. But you may find the things in this video useful because they make nice, pretty tables. And you know, you can take that on with you when you go forth and do your own research. So these are the packages we're going to be using, along with these two, which you probably have not installed yet. So you'll want to comment these 2 lines of code here and install those packages, and then open everything. And then we're going to import the most current version of our data and create a model. This is just an example model, one of the models I've been using. So we have a model object, and to do a forest plot, there is this function here, plot model, that just takes simply the model object and then this little extra argument here, and you get this kind of ugly forest plot over here. It does not. It does allow for some customization. So here are some of the customizations that I. Actually, I think these are the only options. So you can change the title. You can change the axis title. You can change the axis labels. And note that with the axis labels, it actually takes them the reverse of however you have them in your model. So you see I start with Republican and end with education up here, but here I start with education and end with party ID. So, but this allows you to, like, you know, like I have Republican, but down here I call it party ID because when I present the results, I want to have a more general label on it. And same with like female, I don't know, I guess maybe this should be sex rather than gender. And then conservative, I use ideology. These names are, you know, like I've said in the past, useful from you remembering how your data is coded. But when you actually present your results, you want to go back to the actual standard, you know, whatever that variable is. This puts a line somewhere, we'll see in a sec, and it says to make it black. And then this, there's other colors. I'm not sure why I started this and then didn't finish it, but this, you can change these, your dots and lines to other colors, I guess. And then this just tells it what size to make those dots. So all of this customization results in this. Oh yeah, that's the 0 intercept line. I think we might tell you to do that. I don't remember. Yeah. We do tell you to do that. Include this line where the 0 is. You know, again, this is still kind of like boring and ugly, and this is I forget what Rick called it, but like this is actually, the reason they call it a forest plot is because it's usually like turned so that the lines are going up and down, so they look like trees. And then I don't remember, he said for if you leave it horizontal, I think there was some other name that he substituted for it. I just can't remember what it was. Now, if If you don't like this and you want to do some extra fancy stuff, there's more customization that you can do if you use even just the regular plot function in BaseR, or if you use ggplot. But either of those is going to take a data frame with a row for each predictor variable and columns for the name of the predictor, the coefficient, the upper limit of the confidence interval, and the lower limit of the confidence interval. So it knows how long to make these lines. And so I have some code here that kind of walks you through how to do that. You have all that information. It's all in the model. It's just a little bit of data wrangling to extract it. So this here extracts the coefficients from the model and creates a new data frame object. This turns them into actual variables in the data frame and gets rid of the row names as well. See, if you look at this, it has these like row names, and that's not useful when you're doing this process. So this gets rid of those, and it also extracts the upper and lower limit of the confidence interval and creates a variable for each of those. So now if you look at this, you have, oh, I guess it did not get rid of these, but it does add them here, which is you need a column that actually has them in it, because the later steps don't actually recognize this over here as a column. And this just renames each of those columns to something more practical. And then this is the code to create a forest plot in ggplot. So this, again, super basic, just uses your column names that you just gave it up here, and your variable names, and it's just this basic black, and so there's some additional code to change this a little bit. So this part, well, actually we'll come all the way down here, but adding this in here orders the position of the predictors based on the size of the coefficient. So you see now we have it, and this is kind of how they're usually displayed, so that you have like the largest coefficient down to the smallest coefficient. And then if you want to add the next little bit in it, we can rename we can give it a title and then rename the X and Y axis to something more appropriate. And then a little bit more customization. We'll rename those variables, like I said in the other example, to something more more general. And remember, again, these should be backwards from how they are in your model. Or actually backwards, so not backwards for how they are in your model, backwards from the ordering, since this ordered them up here. So before you actually do this part, you're going to want to note, you're going to want to run it through here. Note what order these are in, and flip it. So instead of education, instead of sexism being at the top, you're going to want education to be the first thing that you do, and just flip it all the way down. And then this here little bit, we'll customize it to put in that line that we're asking for at the 0, and this actually made it a dashed line instead of a solid line. And then finally, if you want it to truly be a forest plot and not whatever the other name is that Rick gave it, this final argument chord flip turns it on its side. So that is the forest plot. The next thing is for tables. So If you use LaTeX or Overleaf, there's a couple packages or functions that will export the code to create these nice tables. Stargazer exports regression tables, and Xtable exports more basic tables for things like frequencies. So, and actually I'm going to show you, you don't actually even need to know anything about LaTeX or Overleaf to make this work for you. You can actually run this right in R Markdown, which you are familiar with. So if you run this code here, so this function, you just, of course, replace these variables with whatever variables are in your model. Run it, and it's going to spit out all of this code here. So what you want to do is you want to copy this. And you start with begin table and go down to end table and copy it. And then if you create a new R Markdown file, and it's still, yeah, just down, get rid of that junk. And all you have to do is literally just paste it in there like that and knit it to, you know, Word or PDF or whatever you knit it to. Then it's going to force me to save it. And it will knit your document, and your knitted document will have this lovely table in it. So then you can take like a screenshot or something and just drop that in your document, your write-up, your assignment or whatever. Or like I said, you can, if you are more comfortable in Excel or something like that, or even just creating a table in Word, feel free to do that also. You can also customize this even, so like you could really actually change this to Trump post-election feeling. Maybe we'll just go FD. And change this here to party ID and sex and ideology and sexism scale and actually maybe call this race dummy. And education. Now if I knit it again, see, then you actually have something like more that more effectively communicates. When you are creating your tables, you don't want your variable names in there. You want like what common people will know them as. Okay, so back over here, if you don't want to do all that, you could also just simply create a data frame object with your descriptives in it, and then run it down there in your console and just grab a screenshot of this down here. That works for us too, whichever you think is easiest. This doesn't allow you to change these and make them something more official, but you know, that'll work. Okay, so for regression tables, this package Stargazer, and the function is just Stargazer, creates output similar to this bit, only it's a regression table. And I'm not going to run this because it gives you a really simplified, actually, I will do that. So, and then show you. So it defaults to only giving you the 0.10 and 0.05. Remember, we copy from begin table to end table. And then just come over here. And plop it in. And knit. So note that like you only get these. The p the basic p value is 0.1 and then 0.05 and 0.01. And typically, when you see regression tables, you see this, and then you also see like this is a single asterisk. This is usually a double asterisk, and the triple asterisk is usually the 0.001. And then I always include this, but I give it a little cross because that's, again, what you generally see. So I've actually modified this code over here to include all of this bit here, which will actually fix all that. So run that code. Copy from begin table to end table. Come back over here. And I'm going to paste it over that old stuff. And knit it again. And you see we get this table with all of these down here, and like for example, the sex variable is actually this 0.01, but these others, which didn't even show up on the, well, I think that it probably had them with 3 still, but that was the 0.01 instead of the 0.001. So, again, you do not have to do this, but you could then just screenshot this and then paste it into your Word doc or however you're writing up your assignment. But you could also do that in Excel if you are more comfortable in Excel. So, and then here's, just remember that like this prop table function is very useful when you're describing your sample in particular. You don't have to like include all of this stuff in a table, but we ask you to describe your sample. So let me, what is, yeah, so it says describe the data set you're using, when and how and by whom it is collected. So for that, we're meaning like this, the ANES. So you'll want to kind of look in the ANES code book and kind of, summarize what they say about how they collect their sample. And then also describe the construction of all the variables you're going to be using in your analysis. So you're going to want to tell us if you're using, if you're using party ID, you're going to want to tell us, it's coded, was originally coded on a 7-point scale, and then rescaled from 0 to 1, with 1 representing strong Republican and 0 representing strong Democrat, or, was originally on a 7-point scale and was rescaled from negative 0.5 to positive 0.5, with negative 0.5 representing strong Democrat and positive 0.5 representing strong Republican. You want to be clear to and explain that when you're writing this up. Don't just assume we know how your variables are coded. And then also, it's kind of normal in describing your sample to tell us, like in your sample, if you're using, like just the general demographics of the people in your sample. So tell us, like, what percentage are women and what percentage are Democrat, Independent, Republican. What percentage are, maybe this is a little less useful because it's still on the 7-point scale. There's not really a nice little 3-point, so maybe you wouldn't want to go into that, but you definitely probably want to tell us, like, I don't know what's going on here. I think this is because I coded it differently. Yeah. You definitely want to tell us like the percentage of the different races, average age, average education. These are kind of normal things to report when you are describing your sample. Again, those don't have to go in a table by themselves, but as you're talking about, this is a sample that this is the ANES sample, and then this is how they get it, and this is what it looks like. This is what the people look like that took it. And then finally, on Tuesday, Rick is going to talk a little bit about I forget what this is. Something about two least squares or something least squares, where you are doing, it's like a regression within a regression, and I don't remember exactly how that all works because I don't ever use it. But here are a couple of packages in R that will do this. This is not something that's going to be on the final, but he is going to walk through this this method on Tuesday. And that's it. Hope this stuff was helpful for you, and good luck on the final.